The next thing we need to look at is the effect of the nature of the electrolyte and the concentration of the electrolyte, because we need to predict the products, predict and explain the products of electrolysis based on the nature of the electrolyte and the concentration. So nature just means, is it molten or is it aqueous? So have we actually taken a solid, melted it to create a liquid? Or have we dissolved an ionic compound in water? I can then look at the concentration, so is it dilute or concentrated? So we're going to use sodium chloride as an example to start with, and we're going to start with molten. So if it's molten and it's pure, the only ions that I have present will be sodium ions and chloride ions. So if we think about our electrolysis situation, so we have our negative cathode and our positive anode. Remember, anode is oxidation, and at our cathode, we'll have reduction. So then I've just got to put my electrolyte in. Now, oppositely charged ions will attract, so I'll have my sodium ions go to the cathode and my chloride ions will go to the anode. Then I'm just looking at, well, what happens with reduction of sodium? With sodium, remember, reduction is gain of electrons, so we're going to give it an electron and it's going to make the sodium metal. Notice here I'm not using the aqueous symbol. This is because it isn't aqueous. It's in a molten mixture, so we haven't mixed it with water. Then I'm going to look at the oxidation of chloride. So chloride is the loss of electrons in terms of oxidation. So my electrons need to go on the product side. So I'm going to make my element, which in the case of chlorine is a diatomic, so it's Cl2, and it forms a gas, which means I'm going to need electrons, but because I have two, I'm going to need 2 chlorines and 2 electrons. So the last step I need to do to write the net equation is to actually have balanced the electrons. So I'm going to have 2 electrons here, which means I need to multiply everything in that equation by 2, which my net equation will then end up being 2 sodium. The electrons cancel out because they're on either side of the equation. 2 chloride, and making 2 sodium metal and chlorine gas. So our next situation is looking at, is it dilute or is it concentrated? So I'll just give us a bit of space. Let's start with a dilute solution. This is where we've not added very much salt, but we now have water in the equation. So we can have competing ions with water, could be oxidized, reduced, our hydrogen ion, which from the self-ionization, and our hydroxide from the self-ionization of water. And we also have our sodium and our chloride. So we have our positive and our negative cathodes. And another way of doing this is actually thinking about what's going to be attracted and what's going to potentially be oxidized and reduced. So if we have our positive anode, the negative ions are going to be looking at for oxidation, and the positive ions are going to look at for reduction. So we already know that we have our chloride ion and our sodium. So let's then classify these. So our hydroxide ion is also negative, so it may compete with the chloride, and the hydrogen is also positive, so it may compete with the sodium. Water itself is also on our standard electrode potentials. We can see it here, and we can see it here. So we need to look at the values of water itself as well. So let's look at our reduction side first. So remembering that in our standard electrode potential table, everything on the left has been reduced. So if we're looking for something that a reduction, we need to look for that particular substance on the left-hand side. Whereas if we're looking at oxidation, we need to look for it on the right-hand side. So we can see sodium up here at negative 0.271. So its value is negative 2.71. The hydrogen ion is here, we've found it here. and its value is 0. And then if we look for water, its value is negative 0.83. So for reduction, we're looking for the most positive, the least negative, most positive. So we're looking at that hydrogen. So it's going to be, for our reduction, we're going to have this equation here, so the 2H plus, and in this case it is aqueous, plus 2 electrons to make my hydrogen gas. Then we're going to look at the oxidation. So we're looking on the right-hand side in this one. So our chloride down here at the bottom is positive 1.36. And our OH, we're looking for the OH here, and just checking it doesn't have anything other than water in it, so it's positive 0.4. And then we're looking for our water. We can't use this one because it's also got sulfur dioxide, and we don't have any sulfur dioxide in here. So we need to look at this one here. So it's positive 1.23. Now in this case, because it is dilute and we don't have very much, we're going to look at the fact that the smallest of these, the least positive, is the OH. And remember, we do that because it's oxidation, so it's the reverse. So we're looking at ones above or the less positive, whereas for reduction, it's the ones below or the more positive. So the one that's going to be oxidized is this OH minus, which is this one here. Remember, with oxidation, we start with the oxidized product, so we're reversing the equation. Putting my state symbols in, and my electrons must be on the product side. So it will make oxygen gas, it'll make water, and it's got its electrons. Now to balance out, I'll need to multiply the top equation by 2 because I have 4 electrons here. So it'll really be the 4 hydrogens, 4 electrons to produce 2 hydrogen gases. So my net equation, if I cancel out the 4 electrons, I'll have 4 hydrogen ions, 4 hydroxide ions, which is really, if we look at it as 4 waters, to produce oxygen gas, hydrogen gas, and there's 2 hydrogen gases. Let's fix that up a little. And 2 water. So we have a surplus of water left over, and we have the oxygen gas and the hydrogen gas produced. If you notice, this is very similar to our oxidation of water, which is that we need 2H2O to make oxygen gas and 2 hydrogen. And that's simply because with a dilute solution, you really are just electrolyzing water. Water, if it's pure, can't conduct electricity, so we normally add a small amount of acid, a small amount of base, or a small amount of salt to be able to conduct the electricity to force that electrolysis of water to occur. So that's with dilute. However, concentration does take an effect. So remember, the standard electrode table over here, what it actually is at 1 molar at 25 degrees at 1 atmosphere, so a standard atmosphere and pressure, but 1 molar solutions. So concentration, because these values are close to each other, that concentration can actually make a difference. So if I look up here, I've still got I might just move this up a little bit so we can see our table. So we've still got our values up here. So sodium metal, or sodium ions, they're high in our reactivity. The sodium metal is quite reactive. The sodium ions are very, very stable. So it's very, very hard to actually force this to go the other way. We have to provide a lot of electricity to do that. So this one here, because it's so stable in this form, it's not going to make any difference whatsoever in terms of if we increase the concentration, because my water is now going to be, so I'll have very little of this, I'll have quite a lot of this, but I've still got quite a lot of my water. So this is now still going to be electrolyzed. So I'm still going to have my hydrogen gas being produced. So with concentrated, which is also known as brine, I'm still going to have my hydrogen gas at the cathode. However, at the anode, we notice here I now have very, very small amount of this. So it's really not going to come into effect. I'm going to be looking at the two of these. My concentration of my water has not changed that much. Well, it hasn't changed at all. Whereas my chloride ions, I've now got a much larger concentration of these. And if we think about our equilibrium principles, this is going to, now I have a larger concentration of this. This is going to want to drive this this way more easily, because it's going to try and balance this out. So therefore, what actually happens at the anode is I'll end up getting my chlorine gas. So at the anode, I'll produce my chlorine gas, because there was only a very small difference here, and therefore the equation there is going to be my chlorine ions will produce chlorine gas and 2 electrons, and I'll still produce my hydrogen gas here. So that will still be my this one, or if you prefer, you can use the H2O, this one here. So we can do the 2H2O, which will still give me my hydrogen gas. So you can use this equation, or you can still use your 2H plus your 2 electrons to make hydrogen gas. The products are still the same. Okay, so concentrated, the difference is that we produce chlorine and hydrogen, whereas for dilute, we'll produce our hydrogen still, but we'll produce oxygen gas instead of the chlorine gas.